Okay, I did want to talk about something that is not covered in your reading for Friday, 9/11. You had a exercise to do where you had to read pages, I believe, 1 through 25, and then you had to answer 8 questions. Turn those into Schoology in the Create tab. But I did want to go over something with you that isn't covered in the reading, but it certainly pertains to what's in the reading, and we'll come across this again a little later in the course, but it's stuff you probably would see on the AP CSA exam, and it's important if you're going to go into this field and be a programmer. But here we go. And integers in Java uses 4 bytes, 32 bits. Now, they can be represented as positive or negative numbers, the integers. The largest sign negative number is negative 2147,483,648. And then the largest positive integer is 2147,483,647. Okay, so what happens if an integer is declared as a sign integer? Java splits the 32 bits, if you will, in half. And so if you take a look at 2 raised to 32, that would give you 429,496,7296. And so what happens is that we take that number, 429,496,7296, and it's like we split the bits in half. And if I divide that by 2, you'll get 217. You'll get 2147,483,648. Okay, and so it's like we have 2147,483,648 numbers that are negative, and then we have 2147,483,648 numbers that are positive. But the positive numbers, they begin at 0, and the negative numbers, they begin at -1. And that has a lot to do with 2's complement, okay? But we don't get into that in this class. So it's like, you can look at it like this. You could have 10 digits 0 through 9, okay? Or you could have 10 digits 1 through 10. Or 1 through 10. So in either case, the 0 through 9 kind of like represents what you get with positive integers, 2147,483,647. So the largest positive integer you can represent is 2147,483,647. Okay, you still have 2147,483,648 numbers. It's just that 0 occupies one of the spaces. And then you have 2147,483,648 digits for negative numbers, but it begins at -1 and goes to -2147,483,648. Okay, so and I believe that comes up on the AP CSA exam. The important point is just when we get into actually working with Java, we do have the capability of being able to declare an integer as unsigned, which means then that the largest number you'd be able to represent, if you declare it as unsigned, is just one number short of 429,496,7296. Remembering the largest number you can represent with n digits is 2 raised to the n minus 1. Okay, and that's important because if you're programming and you need a large integer number, more than 2147,483,648, you have to declare that integer as unsigned, and in that way you can get a larger number. Okay, so that's important, particularly with coding. The other thing I wanted to mention, and this is not covered in the textbook, but I did want to go over this because, again, this is one of those things that's important. Let's see here. So we talked about base 2. So here, so what happened? How are like digits or floats represented? So, or decimals, I should say, something like 124.167. How is that represented? Okay. Well, again, we're using base 2, so let's look at this. So 2 to the first is 1, and 2 to the 0 is 1. 2 to the minus 1 is 1/2, and so it's like over here we start to work with the digits in a float. Okay, we start to work with the digits, and then 2 to raise to the minus 2 is 1/4, and 2 raised to the minus 3 is 1/8. Now, why is that important? So this is something I talk about in AP Computer Science Principles. So let's take a look at this. In 1991, the United States used Patriot missiles to defend against the Iraqi military Scud missiles in the U.S.-Iraq War. Unfortunately, the Patriot missile launchers did not work correctly. Among the causes was a software design flaw related to a timer for sending radar detection bursts. The timer was incremented in 0.01 second increments with a cumulative value stored in a coarse binary. Because 1/10 has a denominator with prime factors other than 2. In other words, the increment wasn't like 0.5 or 0.25 or 0.125. Okay, it was 0.1, which is not binary. Because 1/10 has a denominator with prime factors other than 2, this is a repeating binary number. The software truncated the representation, and the small error accumulated over hours of operation. Now, let's see here. The launchers probably, they weren't like 32-bit. They may have been like 16-bit or 2 bytes. But nonetheless, so after the design flaw was discovered, U.S. Army soldiers kept the Patriot missiles launchers powered off when not being deployed so that the error would not accumulate. One launcher that was left powered on accumulated an error of 0.3 seconds before being used to defend against an incoming Scud missile. The Patriot missiles at launch were aimed 0.3 seconds behind the actual position of the incoming Scud missile. The Scud killed 28 Americans when it struck the barracks. So you can see if we were working with a 64-bit computer, 2 raised to minus 4 would give you a very small increment. So it would take a lot longer for it to accumulate error or large error. But if you're working with this much smaller bit computer, 2 raised to the minus, so if it's like 16 bits, well, that's going to be larger than 2 raised to the minus 64. So I think the launcher was probably not a 64-bit device. It could have been like 32-bit or 16. But anyway, so that's important as well. So again, if you ever go into the business, join the military, keep that in mind, because again, computers, they're base 2, and unless your increment is some factor of base 2, then you will get some truncation occurring, okay, as things get added. So anyway, that's all I had to say regarding the lesson.